Hi, and welcome to the section 4 of this course, Azure Storage Queues. In this section, we will take a look at the event-driven programming practices. We will take a look at how a queue, which is a data structure, or the message queues can serve the larger programming paradigm of Internet of Things. We will also take a look at Azure Storage and the service level agreements that it offers for queuing or messaging services. In this first video, we will take a look at the introduction of Azure Storage Queues, and we will see the event-driven programming practice, what it is, how the serverless apps function, and how we can trigger the applications through enqueuing or dequeuing of the messages in the queues. Azure Queue Service acts as a container that contains all the queues or the message queues for our applications and the programs to process. Azure Queue Service supports operations such as enqueuing the messages or dequeuing the messages. The performance of the Azure Queue Service is similar to the Azure Queue SLA that is offered across all the services, the blobs, tables, files, and the Azure Queue Service. To better understand the purpose of the queuing or message-oriented applications, we need to take a look at the reactive systems and what a reactive system is. In a reactive system, you have an event hub, which can be a program that listens to all the events happening across the app domain. And whenever a user has to issue a command, publish some data, or to start some virtual machines, let's say, he submits a message to the event queue. The queue is being monitored by a special program which we will discuss as a serverless application in the coming modules. That serverless application listens to the events in the event hub, such as enqueuing of the messages, and then it processes all the information in that message to perform an action such as processing the data or starting the virtual machines. The benefit of a reactive system is that it is non-blocking in nature, which means that instead of having to wait for an operation to complete, it performs another operation in the meantime, thus being efficient. It also consumes less resources because most of the reactive systems consume only a single thread, such as a Node.js application. And since a reactive system is event-driven in nature, it uses a trigger to execute an operation, task, or start some machines, and so on. The new microservice architectures support reactive approaches because they are resource efficient and perform better, while providing the scalability and responsiveness. Azure Functions is the primary and the only service offered by Microsoft in the serverless environment. Azure Storage Queue has a built-in functionality to act as a trigger for Azure Functions. And lastly, any of our IoT application or a program can initiate or trigger any application while being connected to Azure Function. There is a lot more to discuss about Azure Queues, which we will discuss in the demo module later on.